Hey everyone. So today we're working on something called trig substitution. It is another technique that you can use to integrate. There are also other ways you can do it. So as we go through the problems, there might be some that you might see that you could do in another way. For instance, like force the one method, knowing how to get it into a format that is something with inverse trig, or maybe doing something with completing the square or something along those lines. So just remember that there are other ways to go about doing it. But hopefully, as we do this, these will make sense. Okay, so you have a packet in front of you, and you are going to start with this first problem. There are three situations that we're going to look at. At the end, we will kind of put it all together so you can try to remember how to do it. So we're trying to solve a problem that has a square root in it that takes on this form. So the square root of a squared minus x squared, where x is the variable and a is a constant. So what you're going to do to help yourself make this work is you are going to draw, at least for the time being, you will draw a right triangle, theta down in the corner. And in this situation with the constant squared minus the variable squared, you will make the variable be the side across from theta, and the hypotenuse will be a, which means that the missing side will become the square root of a squared minus x squared. So I'm doing some Pythagorean theorem here. If you're not sure what I did to get there, go ahead and take a minute, pause the video and figure it out. Okay, so then when this happens, you can set up a bunch of different trig ratios. And the goal here is to substitute some trig stuff into the problem and then evaluate and then resubstitute in. Okay, so I'm going to set a few things up. I'm going to go through it the long way for this one, and on the next two situations, I'll go a little bit faster. So hopefully you can see that if you use SOHCAHTOA, sine of theta will be equal to x over a, which means that a times sine of theta will equal x. Okay, so this is the first thing you want to start off with. And hang on a second, my pad here is having a hard time writing it. Let's see if I can fix this. All right, let's see if this is better. Anyway, and then you want to think of what the derivative of dx is, or the derivative of x, which is dx, is because you want to substitute in for dx. So that would become a cosine theta is equal to, oops, I forgot my d theta. D theta equals dx. Okay, so for every one of these problems you set up, it should look like this. And then you also need to substitute for, you see how in this problem I have the square root piece that has to go away as well. So that would be equal to cosine of theta equals adjacent square root of a squared minus x squared over the hypotenuse a. Or you could jump right to a cosine theta is equal to the square root of a squared minus x squared. So these three things over here, you're going to substitute into your integral. Okay, so for this first problem, I'm going to draw a new triangle. Maybe I'll try and draw a better triangle than that. How about I just draw one with an actual picture? Okay, so I'm going to set it up in the same way as I set up the other one, but now I'm just going to be using actual numbers. All right, so theta down here. And since it was the square root of 4 minus x squared, the square root of 4 minus x squared is going to go down on this side. And then x goes as the opposite side, and then the square root of 4, or 2, goes here. And we're going to use this box of information to set up some stuff that we can use to substitute into our integral. Okay, so a is 2 here. So 2 sine theta equals x. This means 2 cosine theta, d theta equals dx. So I'm just using this information, but you could, of course, take the derivative right here. And it also means 2 cosine theta also equals the square root of 4 minus x squared. So I'm going to take all of that, I'm going to substitute it into my original integral, which obviously is on your paper, but I'm going to rewrite here. Okay, so this becomes 8 times, and I'm going to substitute dx into the problem. So 2 cosine theta d theta in the numerator. And the denominator actually needs an x squared, so I'm going to replace that with 4 sine squared theta. And then the square root of 4 minus x squared is 2 cosine theta. So again, all we're trying to do is trying to make this into something that will be easier to take the integral of. It doesn't look that much easier right now, but it will become easier here. All right, so I'm going to cancel the 2 cosine thetas. I'm going to reduce, that becomes a 2, and I am left with 2 times the integral of 1 over sine squared theta. 1 over sine squared is the same as cosecant squared theta d theta. And hopefully you remember that cosecant squared is the derivative of negative cotangent. So this becomes negative 2 cotangent theta plus c. Okay, so this is great. That's great. But we have to actually get rid of the trig and the theta because remember the original problem was in terms of x. So I want to go back to this triangle and figure out what is cotangent equal to. Well, cotangent is adjacent over opposite. So I'm going to replace cotangent of theta with the square root of 4 minus x squared over x. So I'm using its trig ratio to rewrite this. So negative 2 times the square root of 4 minus x squared over x plus c. And obviously you don't need those parentheses, and you could put the negative 2 in the numerator, but this is it, okay? All right, so let's move on to our second situation. So the second situation now is when you have the square root of a squared plus x squared. So you have a constant squared plus the variable squared. So same picture is going to start off with your theta in the corner. X will be your opposite side still on this problem. And now the adjacent side becomes a, which means by Pythagorean theorem, you have the square root of a squared plus x squared as your hypotenuse. Okay, and I'm actually going to put this information like I did in the problem up here, so I'm not using up all the space over here. So I am going to start by recognizing, well, if I do tangent, I want to try to make it as simple as possible. So I want to use the a in the problem. So I want to figure out what x is equal to, and I want to figure out what the square root is equal to. And I want to use the a because that's a constant. So I know that tangent of theta is equal to opposite over adjacent, which means a times tangent theta will be equal to x. And I want to use the square root part, and I want to use the a to come up with another ratio. So I look at that and I see cosine, but that puts this ugly thing in the denominator. So I'm going to use secant instead so that I don't have that radical in the denominator. So secant is equal to the hypotenuse over the adjacent side, which means a secant theta is equal to the square root of a squared plus x squared. So I've got those two things defined. And then finally, I do need to have something written for the derivative because I need to have a dx. Let's actually use this one. So the derivative of tangent is secant squared. So a secant squared theta d theta is equal to dx. Okay, so we are going to use, again, that situation to try and set up a triangle and a problem for this one here. Now, this one we can actually do in a different way, maybe get a different answer, actually several different answers. I'm going to do this with the trig substitution method that I'm teaching you right now, but hopefully you can take a moment and recognize this for what it is, which at the end I'll talk about that. All right, so my x goes on the opposite side, 1 goes on the adjacent side, and square root of x squared plus 1 is the hypotenuse. Okay, so I know that tangent of theta is equal to x, which means secant squared theta d theta equals dx. And 1 times secant, or just secant theta, is equal to the square root of x squared plus 1. All right, I'm going to substitute everything in here. So dx is equal to secant squared theta d theta, and the square root of x squared plus 1 is equal to secant theta. Well, this is just equal to the integral of secant theta d theta, which seems awfully simplified, but in reality, this is not something we have practiced. This actually needs what's called an integral from the trig table in the back of your book. I wish that this were not the case, but I do want to show you this. This is from page 631 in your book. I'm not going to actually have a picture of the book here. You can turn there and look yourself. But the page 631 tells us that the antiderivative of secant theta d theta is equal to the natural log of the absolute value of secant of theta plus tangent of theta. Okay, this is what it's equal to, but I don't like this. I have to replace the secant and the tangent. So secant is equal to the square root of x squared plus 1, and tangent is equal to x. So this is the answer using this trig substitution method. Now, hopefully, is when you have x squared minus a squared. So again, x is the variable, a is the constant. Since we're thinking Pythagorean theorem, this thing has to go as the hypotenuse. The x has to go as the hypotenuse. So we are going to set it up with the a being on the adjacent side. You will probably want to try and see what happens if you put the a over here, and I'll tell you right now it doesn't work very well, but you are welcome to give it a try and see what happens. So that means this side is equal to the square root of x squared minus a squared. Okay, so that means when I go to do my trig setups, I'm going to use that secant setup that I did from the last problem, where I'm going to say secant is equal to the hypotenuse over adjacent, and I'm just going to throw the adjacent side out front. And then this is the opposite over adjacent, so this is actually a tangent setup. So tangent of theta is equal to opposite over adjacent, and I'm going to put that adjacent over here. And I need to know what the derivative is equal to. I need to have dx. I certainly don't want to mess with that. The derivative of secant is secant theta tangent theta d theta equals dx. Okay, again, we're only able to use these when you have the square root situation. So keep in mind that's what you're looking for in the problem. So this one over here does have a square root. It also has an x cubed, which is kind of a mess. At least it looks like it. Let's see what happens. Okay, so this looks pretty straightforward. X goes here, 1 goes here. Square root of x squared minus 1 goes on this side. So that means secant of theta just equals x, which means secant theta tangent theta d theta equals dx. It also, by the way, means secant cubed theta equals x cubed, since I'm going to have to substitute that in. And it also means that tangent theta is equal to x squared minus 1. So again, we're just rewriting things in trig form, in a trig form, because the trig doesn't have all those radicals and everything in it, so it's supposed to make it a little bit easier. Sometimes it does, sometimes it doesn't. Okay, this problem, 2 dx. dx is secant theta, tangent theta d theta. X cubed is secant cubed theta, and the square root part is equal to tangent theta. So now I am going to do some simplifying. I want to just go a little bit farther if I can. Okay. So tangent theta cancel. The secant cancels with that secant, and we end up with secant squared in the denominator, but secant squared is the same as cosine squared in the numerator, so it becomes this. Okay, so this situation here is another kind of problematic instance. I believe I have it on the front of your packet where there are a couple extra formulas you need to memorize. Sorry, just adding some more just memorization on there. But the formula that you want to know here is that cosine squared is equal to 1 plus 2 cosine theta over 2. So we're going to do some simplification of this problem by substituting this over here. So I have 2 times the integral of 1 plus 2 cosine theta over 2 d theta. And obviously those 2's can cancel. So now I'm left with the integral of 1 plus 2 cosine theta. I'm going to separate that. Actually, no, I'm just going to write it like this. 1 plus 2 cosine theta d theta. And 1, then in the situation we're talking about, this is theta. 1 just becomes theta. And then the antiderivative of cosine is sine. So this is theta plus 2 sine theta plus c. Okay, well, I need to remember what my triangle looks like. I'll draw a quick another sketch over here so I don't have to scroll up. So this was x1 square root of x squared minus 1, theta here. So theta itself, we want to rewrite it as something in terms of x. So I'm going to go back to my original setup, which said secant of theta equals x. That means theta equals inverse secant of x. So inverse secant of x goes here. And sine, we know, is equal to opposite over hypotenuse. So my opposite is the square root of x squared minus 1 over hypotenuse of x plus c. This problem, it would be really hard for us to find another way to do it. You could probably replace this with some other inverse trig function. You could also take the time and actually take the derivative of this and find that it works. So just keep in mind that there's a couple of different routes you can go, especially towards the end here. This is definitely what you would see in the back of the book. Okay, so we have now learned 3 different ways or 3 different situations. And I want to kind of summarize them here for you. So if there's space at the back of your paper or someplace on an extra piece of notes, you want to do that. So you have 3 square roots that you're dealing with, and that's what we're looking for to do this trig substitution. So the first one we did, it was the square root of a squared minus x squared, and we put that on the adjacent side. By doing that, that creates the opposite side as x and the hypotenuse is a, which is how I get x equal to a sine theta. Okay. The second situation that we came up with is the square root of a squared plus x squared. Well, if that's the situation, that has to go on the hypotenuse, which then means that I have to give the opposite side the x and the adjacent side the a. And when this happens, that's how I create the a tangent theta equals x. And finally, when we have the square root of x squared minus a squared, this means that we have to put the x as the hypotenuse and the a as the adjacent side here, which when we do this, this is how we create a secant theta equals x. So if you want to take a moment and write this situation down, or this like little graphic down so you can see the setup, maybe even fill in with what the derivatives of each of these are. Notice what changes each time is where you're putting the square root. So there's 1 square root on the adjacent side, 1 square root on the hypotenuse, and 1 square root on the opposite. However, the a and the x, that's a little bit harder to figure out. So try and remember that if it's the adjacent side that you're putting the square root, you're going to get a sine problem. If it's the hypotenuse, you're going to get a tangent. And if it's the opposite, you're going to get a secant. Okay, we're going to do one more. I'm going to do one more. Here are those formulas again I was talking about. This one I believe is written wrong, so we're going to skip that for now. We're just going to talk about number 1 and then be done so that the video isn't too long. Okay, so I'm going to draw my triangle. theta here, and I see that this is a subtraction problem. So since this is subtraction, that means that my, excuse me, um, square root is going to go down here. Okay, and again, have that little graphic in front of you so you know what's going on. Well, subtraction with the constant first, I guess I should clarify that. And then the opposite side gets the x, and the hypotenuse in this case is going to get the square root of 9, which is 3. Okay. So now I need to know that x is equal to 3 sine theta, which means that dx is equal to 3 cosine theta d theta. Notice we also need to know what x squared is equal to. So x squared is equal to 9 sine squared theta. And then I need to know what the square root of 9 minus x squared is. Well, the square root of 9 minus x squared equals 3 cosine theta. Now, I'm doing this kind of from memory, but you can do trig every single time. So this is adjacent over hypotenuse, and I then multiplied the hypotenuse to the other side. Okay, so I'm going to fill that in. Dx is then, like we said, 3 cosine theta d theta. And then the denominator becomes 9 sine squared theta, and then times 3 cosine theta. And as you can see, the 3 cosine cancel, and you are left with 1/9 times the integral of, this is 1 over sine squared, which is cosecant squared theta d theta, which the antiderivative of cosecant squared is negative cotangent. So this is negative 1/9 cotangent theta plus c. And I need to go back to my picture to figure out what cotangent of theta is equal to. Cotangent is adjacent over opposite. So this final answer becomes negative square root of 9 minus x squared over 9x, of course, plus c. Feel free to leave the 1/9 out front, whatever is more comfortable for you. Okay, I'm going to skip this one as well, but I would like you to try it and see if you can figure out what the solution will be to this problem, and we'll start that class period off tomorrow with that.